Here's problem 2410. Charge of uniform density 8 nanocoulombs per square meter is distributed over the entire xy plane. A charge of uniform density 3 nanocoulombs per square meter is distributed over the parallel plane defined by z equal 2. Determine the magnitude of the electric field for any point with z equal to 3 meters. Alright, let's imagine what's going on here. Let's say we have x, actually let's make this y, and this x, and this z. And we got 1, 2, 3. And we've got the whole xy plane has an infinite sheet of charge. And that sigma is equal to 8 nanocoulombs per square meter. And then at z equal to 2, we've got another plane, infinite plane of charge, also positive, and that's equal to 3 nanocoulombs per meter squared. And we want to find the electric field at z equal to 3 at some point P where z is equal to 3. Looking at this, from the first plane we're going to have an electric field that's emanating away from the positive plane. So we're going to have a field E1 that's going up like this. And then from the second plane we're going to have a field that's also emanating away. So we have a field E2 that's also going up like that. So these two fields are going to be adding together in the same direction. And they both will be constant given by sigma over 2 epsilon naught for an infinite sheet of charge. So let's calculate the magnitude of these two fields and add them together. E1 is going to equal sigma 1 over 2 epsilon naught. And that's going to equal 8 nanocoulombs, 8 times 10 to the minus 9, over 2 times 8.85 times 10 to the minus 12. And what is that? (451.98), so we could say 452 newtons per coulomb in the positive z direction, which would be up as we're looking at. E2 is going to equal sigma 2 over 2 epsilon naught. And that's going to be 3 nanocoulombs over 2 times 8.85 times 10 to the minus 12. And what is that? Should be 1/3 of the other one. 169.5. Or I'm sorry, 3/8 of the other one. Newtons per coulomb, also in the positive z direction. So these two fields are going to add. Our net field is going to be the sum of the two. That's going to be 452 plus 169.5, and that's going to equal 621.5 newtons per coulomb in the positive z direction. So that's the magnitude of our net field, 621.5 newtons per coulomb in the positive z direction. Answer.